Welcome to the Albert AI Hub, where we unravel the mysteries of artificial intelligence. Picture a world where machines mimic us, learning and problem-solving just like humans. That's the essence of AI. Now, there are two main types of AI to consider. First, we have artificial narrow intelligence, designed for specific tasks. Then, there's the hypothetical artificial general intelligence, which would possess human-level cognitive abilities. Ever wonder how machines can seemingly think and learn? Buckle up, as we're about to dive into the fascinating world of artificial intelligence. One of the core principles in AI is machine learning, the ability of machines to learn from experience. Now let's break this down. Think about a child learning to recognize a dog. At first, the child might just see a bunch of different furry creatures. But over time, by seeing different dogs, the child begins to recognize common features: four legs, wagging tail, big eyes. This is how the child learns to recognize a dog. Machine learning operates on a similar principle, but instead of learning to recognize dogs, AI learns to recognize patterns in data, and instead of seeing a few dogs a day, AI can analyze millions, even billions of data points in a fraction of the time. This is essentially how machine learning works. AI is given a task, say, to identify spam emails. It starts by analyzing a large data set of emails that have been labeled as either spam or not spam. This is like showing the child lots of pictures of dogs and saying, this is a dog, and this isn't a dog. As AI goes through these emails, it begins to recognize patterns. It might notice, for instance, that spam emails often contain certain phrases or come from specific email addresses. Once it has analyzed enough emails, AI can begin to predict whether a new, unlabeled email is spam or not, based on the patterns it has learned. This is a process called training. Just like how a child learns over time to recognize a dog, AI learns over time to recognize spam emails. The more data it has to learn from, the better it gets at its task. However, machine learning isn't just about pattern recognition. It's also about adaptation. Let's say our AI system incorrectly labels a not spam email as spam. When this error is identified, the system can adjust its internal model, refining the patterns it recognizes. This is similar to how a child might initially mistake a cat for a dog, but learns to differentiate as they gain more experience. So, in a nutshell, machine learning is a process where AI learns from experience, identifies patterns in data, and adapts its behavior based on those patterns. It's a continuous cycle of learning and adapting, and it's this ability to learn from experience that makes AI so powerful. But remember, just like a child needs guidance to learn correctly, AI needs guidance too. It needs good quality data to learn from, and it needs careful monitoring to ensure it's learning the right things. After all, we wouldn't want our AI to start thinking that all emails are spam, would we? Just like a child learns to recognize objects, AI learns by identifying patterns in the data it analyzes. And that, my friends, is the fascinating process of machine learning in a nutshell. AI is not a one-size-fits-all solution. It uses different techniques based on the task at hand. With that, let's dive into the world of different AI techniques. To start, we have supervised learning. Imagine a teacher guiding a student through a textbook. The teacher points out important details, corrects mistakes, and provides answers when the student is confused. This is similar to how supervised learning works. In this technique, AI is given a set of input data along with the correct output. It's like showing a child a picture of a dog and saying, this is a dog. The AI analyzes the input and output, learning the relationship between the two. It's then able to apply this learning to new, unseen data. An everyday example of supervised learning is spam filtering in emails. The AI is trained with emails that are labeled as spam or not spam. Over time, it learns to identify the characteristics of a spam email, like certain keywords or suspicious links. So, the next time you find a suspicious email in your spam folder, you've got supervised learning to thank. Next, let's talk about unsupervised learning. This is like a student exploring a library without a guide. The student doesn't have a definite goal, but learns by discovering and connecting patterns in the books they read. Similarly, in unsupervised learning, the AI is given a data set but no specific output. It's like showing a child a picture without telling them what it is. The AI must find patterns and structures in the data all on its own. A common use of unsupervised learning is in customer segmentation. Businesses often have large amounts of data about their customers but may not know what to do with it. Unsupervised learning can analyze this data and group customers based on similarities like age, buying habits, or location. This helps businesses tailor their marketing strategies to different customer groups, making their campaigns more effective. Lastly, we've got reinforcement learning. This is like a child learning to ride a bike. They try to balance and pedal, they fall, they try again, and slowly but surely they learn. In reinforcement learning, an AI bot performs actions in an environment to achieve a goal. It receives rewards for good actions and penalties for bad ones. Through trial and error, it learns to make the best decisions to maximize its rewards. One exciting example of reinforcement learning is AI bots learning to play games. Google's DeepMind developed an AI named AlphaGo that used reinforcement learning to become a world champion at the complex board game Go. AlphaGo played millions of games against itself, learning from its mistakes and improving its strategies with each game. So there you have it, from supervised learning guiding AI like a teacher, to unsupervised learning letting AI discover patterns on its own, to reinforcement learning allowing AI to learn from trial and error. These techniques show the incredible adaptability of AI. And it's not just about academic interest. These techniques have real-world applications that impact our lives every day. From spam filtering to customer segmentation, from playing games to predicting trends, AI techniques are diverse and versatile. So, the next time you benefit from a personalized recommendation or marvel at a self-driving car, remember, there's a unique AI technique working behind the scenes, making it all possible. AI is not just about machines and algorithms, it's about transforming lives and industries. Picture this. A doctor uses AI to analyze medical images and detect diseases at their earliest stages, potentially saving millions of lives every year. Or imagine a financial analyst leveraging AI to predict market trends, leading to more informed investment decisions. And let's not forget the self-driving cars that could significantly reduce traffic accidents and free up hours of time currently spent behind the wheel. These are not scenes from a futuristic sci-fi movie, but real-world applications of AI that are happening today. From healthcare to finance, transportation to entertainment, AI is making remarkable strides and delivering benefits that were once unimaginable. In healthcare, AI algorithms can analyze medical images with a level of detail that surpasses human capability, aiding in early disease detection. In finance, AI can analyze vast amounts of market data to predict trends, helping investors make smarter decisions. In transportation, AI powers self-driving cars, promising safer roads and more efficient commutes. And in entertainment, AI recommendation systems curate personalized content, enhancing our leisure time. But like any powerful tool, AI comes with its share of challenges. The development of AI systems that can outperform humans in most economically valuable work could lead to significant societal changes, including job displacement. There are also concerns about privacy and security, particularly when AI is used to analyze personal data. Moreover, AI's ability to learn from data means that it can also learn and perpetuate biases present in that data. If not carefully managed, this could lead to unfair outcomes in critical areas like hiring or lending. These challenges underscore the importance of developing AI responsibly. We need to strike a balance between leveraging AI's immense potential and mitigating its risks. This involves thoughtful regulation, robust privacy protections, and ongoing research to ensure fairness and transparency. AI has the potential to revolutionize our world, but it's crucial to develop it responsibly. With the right approach, AI can be a force for good, transforming lives and industries for the better. So that's a brief overview of how AI works, from mimicking human cognitive abilities, learning through vast data analysis, to utilizing different techniques like supervised, unsupervised, and reinforcement learning. We've also touched on the potential and limitations of AI in various fields. It's a fascinating world, filled with endless possibilities and challenges. As we step into the future, let's continue to explore and understand this exciting realm of technology. Don't forget to subscribe for more AI-related content and leave with your thoughts on AI. We sincerely thank you for your time and engagement. Your support means a lot to us. Until next time, keep exploring.